This is Exponents video number 1 called Squares and Cubes. You may remember from our work with the Pythagorean theorem that we investigated the area of a square. And to find the area of a rectangle, the formula is area equals length by width. And since a square has the same side lengths on all four sides, we can really call that area equals side times side, and a more efficient way to write that is side squared, or side to the second power. So for example, in a square, if one side was 5 inches, then we know the other side would have to be 5 inches as well. So the area of this square would be 5 squared, or 25 square inches. Likewise, if we had a square that was 7 meters on a side, the area would be 7 squared, or 49 square meters. You might also remember that the numbers 25 and 49 are examples of what we call perfect square numbers, or just square numbers. You might also remember that there is a relationship between the area of a square and the side lengths of a square. For example, in the first square we looked at, the area is 25 square inches, and the side lengths are 5 inches. Now, the 5-inch side length is the square root of the area of that square. So likewise, in the lower square, if we have an area of 49 square meters, then the square root of 49 is the side length of 7, and that's why 49 is called a perfect square. 7 times 7 equals 49, and the square root of 49 equals a perfect 7. Now, in a similar way, the side lengths, or the edge of a cube, and its volume are related. If you look at the cube on this page, it has a length of 4, and a height of 4, and a width of 4. So you can count 4 little cubes going this way, and 4 going up, and 4 across the front. And so we can use that to find the volume of a cube. The volume of a cube would be the side times the side times the side. Or another way to write that more efficiently would be a side to the third power. We call that side cubed because it comes from the volume of a cube. So in this case, our volume would be volume equals 4 to the third power. And that's how we write it in exponential form. And we could expand that out to find the value, which would be 4 times 4 times 4, and that would have a total value of 64. So 64 cubic units would fit into a box the size of our cube on the edge of the screen. So the volume of a cube is how many cubic units would fit into a box that size, in this case a 1 by 1 by 1 cube. If you look at the cube on our screen, there's 4 cubes stacked along the bottom of this first section, there's 4 more on top of that, and there's 4 more on top of that, and there's 4 more on top of that. So this front layer right here would be 16 cubes stacked up, or 4 times 4. Now if you notice, there'll be another layer just like that behind it, another layer behind that, and another layer behind that. So there's 4 of those layers. So if each layer is 4 by 4, and there are 4 layers, we could find out how many cubes by 4 times 4 times 4, well, 4 to the third power, which again we call 4 cubed. We can record this data on a data sheet like the one on the screen, and we can see if there's any patterns we notice about cubes and their side lengths as compared to their volume. So if I took the example we already used, the side length of 4, the sides would be 4, 4, and 4. And when I write that in exponential form, we'd write 4 to the third power. Then volume in standard form would be the value of that, how many cubes I would fit, which is that 64 number. So standard form for 4 to the third, or the volume of that cube, would be 64. And then if we take what we call the cube root of 64, in other words, what number times itself 3 times gives you 64, we would find that would be 4 also. We could continue that pattern with many examples. So for The next one we would use a 5 by 5 by 5 cube. And in exponential form we would write 5 to the third power. And that volume, 5 times 5 is 25, times another 5 is 125. That would be the standard form or volume of a cube with edges or side lengths of 5. The cube root of 125 then, or the cube root of the volume, would give you the side length of 5. So after you've completed a data sheet like the one on the previous screen, you may notice a pattern that shows the relationship between the edge or the side length of the cube and its volume. The volume of a cube is side to the third power. So if I know a side of the cube, I can times it by itself 3 times and find the volume. And the inverse of that is also true. If I know the volume and I take the cube root of the volume, I get the side length. So if I already knew how many cubes could fit in a box, I could find the cube root of that and find the edge or the side length of the cube. It's similar to how the side of a square and the area of a square are related. That concludes video number 1 on exponents called squares and cubes. To find out how exponents work when they're multiplied, look at video number 2.